We've talked about acids and bases and their strengths. But if we want to compare the strengths of several acids or several bases, we need to know the values of Ka or Kb. That information is summarized on what we'll call the acid-base chart or the acid-base table. Here is a typical acid-base chart or acid-base table similar to the one found in our textbook. We've added some thick lines to it, and we'll see why in a couple of minutes. The first thing to notice is the column headings. The entries on the left-hand side of the table are acids, while the entries on the right are bases. And on every single line is a conjugate pair. For example, across the table from hydrofluoric acid is the fluoride ion. The middle column on the table shows the value of the Kas for each of the acids. Ka for HF is 7.2 times 10 to the minus fourth power. If you look carefully at the values of Ka, the entries above the thick line near the top are all greater than 1. We said that a value of Ka greater than 1 indicates a strong acid, so all of the entries above the top thick line are strong acids. The first entry below the line is hydronium, with a Ka of 1. This makes sense if you think about the reaction this equilibrium constant refers to. The reaction of an acid with water. The products are the same as the reactants, and the expression for the equilibrium constant has the same numerator and denominator. Looking carefully at the values of Ka for the entries below hydronium, they are all less than 1, which is an indication of a weak acid. Not only that, but as you go down the list, the numbers get smaller. So the entries in the table are in order of strength, with the acids getting weaker as you go down. There's also a thick line near the bottom of the table. The two entries there are ammonia and hydroxide. We don't think of these as acids at all. In fact, they both show up on the base side of the table. So why are they listed on the acid side? Remember that these are all conjugate pairs, and these two happen to be conjugate acids of the strong bases oxide, O2-, and the amide ion, NH2, 1-. So the bases below the bottom thick line are strong bases, and for their conjugates, which really don't act as acids in water at all, we'll label them non-acidic. Any bases above that bottom thick line are weak bases by our definition, and their strength is in order, with the bases getting weaker going up. Finally, the bases above the top thick line, across from the strong acids, are weaker than water. Notice that water is the first entry on the base side below that line. So those bases above the line really don't act as bases at all in water, and we'll label them non-basic. This acid-base chart is not only for comparing strengths of different acids and different bases, but we'll also use it for assisting us in writing balanced equations for acid-base reactions, and it will allow us to determine if those reactions are extensive.